Hello, everybody, and welcome back to the channel. Thank you very much, guys, for reaching this step in our learning. It's just even the beginning. Data science is it's a pretty long process. It's a pretty good field, and we are constantly learning. As data scientists, we need to keep learning. We need to keep being up to date with what is the new technologies and because sometimes what is up to date today might not be up to date tomorrow, and you really have to, as a data scientist, to keep learning. I am still learning new things. Even like the best data scientists in the world are still learning because there's something new every day. It's a pretty evolving field, and with all of these tools that are created every day, we can't do nothing but just to learn that. Because if you don't want to stay behind or stay obsolete with what is new as technology or as new data science tools, you have to put on the work to keep learning. But the good thing is what we're learning now, exploratory data analysis, cleaning the data, are things that are always going to be up to date in data science. We need those steps to perform or to complete a very well-crafted data science project. So data cleaning, EDA, and what we're going to be learning next are always going to be up to date, no matter what new technology arises and no matter what new tools we're using now to perform a data science task. It's still going to be involving EDA, data cleaning, and the next things we are going to be learning. So before further delay, let's get started. During the previous tutorials, we very focusing on um, exploratory data analysis as a huge part of the data science project, and I wanted to do this hands-on project to perform a complete exploratory data analysis and tell you guys, and so that you can see how we can start from a data set with nothing, with like less to zero information about the data, to a transformed data where we actually have like way more insights and we can use this insight for any problem we want to solve. In this case, the data set we are using is the cars data. You guys, if you follow or if you've already read the last tutorials, you know that this is a data set we have been using for the past courses. And again, first of all, the first thing is always import your data set. And as I told you last time, I'm using Google Colab, but I would recommend you to use Jupyter Notebook for a beginner. And once you get very comfortable with Google Colab, you can actually go ahead. Once you get comfortable with Jupyter Notebook, you can actually go ahead and start exploring other tools for data science like Google Colab. Google Colab is awesome, but it requires you to have internet when you perform tasks. Unlike Jupyter Notebook that is free, no internet, and you perform some very good data science tasks with it. So go ahead and open your Jupyter Notebook and follow this tutorial. And this is our data set we're importing. And oop, yeah, this is our data set. And the only thing we actually have is the only thing we know right now is just like we know nothing. Now we want to know. The first thing you want to have a data set is you want to know how the data looks like. What are the features? What are all attributes of data set? How the data looks like? How are the features? What are the features? Are they integers? Are they floats? Are they object? Are they strings? So you want to know how the data looks like first of all. What is better than just using the function heads to tell you that? It's a very powerful function and a function that you will never you will never skip using ever. I mean, you're gonna use this function every time for sure. Um, Data function cars data dot head, and this is just how our data looks like. We have some of the columns includes the make of the car, the model of the car, the year, their transmission type, the number of door, the market category, and popularity, the city MPG, and the MSRP. MSRP here stands for the manufacturer suggested retail price. This is type of data where we have collected information about car's attributes, and we want to predict the price, the retail price of the car based on all of those attributes. And you guys know that, for instance, here we want to predict the retail price of the car based on the popularity, the city, the vehicle's type, the vehicle size, the market category, and some of the attribute that probably everybody knows, that are the make of the car, the model of the car, and the year of the car. Those are very important features when we want to predict or when we want to determine the retail price of a car. And this is what we're working on as a data set. Now that we know how the data looks like, let's move forward and get some information about the data set. The function .info gives you like some basic information about the data set. And this is a function that you also work with it every time. Never lose the opportunity to use this function, because it gives you so much in such a short time, in such a short line of code. Cars data.info, and with that we can already know how many entries or how many rows we have in the data set. 11,914 rows. And how many columns we have in the data set? 16 columns. Yeah, and those columns include the make, the model, the year, as we've seen previously. And also something very good is the data type is already here. Object for make and model, integer for year, float for engine HP, integer for the retail price. It's kind of funny because the retail price is an integer. Maybe they just wanted to round up the prices in the data sets to integer values rather than using float. But usually sometimes some prices could be float, but like in the market, when you see usually in the market, the prices are integers, like $18,000, $15,000, $2,000, $4,000. That's pretty good. That's pretty accurate, and that reflects how the market looks like in real life. And something very good that we can learn from the e.info function is usually for each attribute or for each column of a data set, the .info function tells you how many non-null values that attribute has. For instance, the make model has 11,914 non-null values, and a column like the market category has 8,172 non-null values. Usually, this is the best way, one of the best ways to determine which columns have some missing values. How do we determine that? When the number of non-null values for that attribute does not equal the number of entries in the data set, that means that the attribute has some missing values. And this is really like this kind of gives you a glimpse of what the .info function does and how we can first of all identify which column have some missing values. This is one of the best ways to identify missing values. And the best way is obviously using the missing values that is null function that we're going to be looking at previously. We're going to be looking at soon. But right now, let's look at another way to describe the data set. Is using this function .describe. This function .describe is just a function that gives you a bigger picture of how the attributes of the data sets are. Usually the counts of the values, what is the average values, what is the average values for that column, what is the minimum, what is the maximum, what is the standard deviation. And you guys might already tell me that, oh, why is we have less attributes than the number of attributes in the data set? Just because when you use a function .describe, you usually use that for numerical attributes only. For instance, there's no way you can get the mean values for a non-numerical attribute. For instance, is there like a way to determine the mean of the make attributes? No, because the values are object, the values are the numerical. Numerical is something that we knew. We can use mathematics, some of the basic mathematics operations to get the values with the mean, the median, the minimum, the maximum, the standard deviation. And Usually those are some basic statistics we want to know about the data set, and sometimes it's pretty helpful to determine if there's anything that doesn't make sense about the values in the data set. But if you really want to include all of the columns in the data set, you can add this functionality, this option like use the describe function and you include equal all. Include equals all tells me that even if the data type of the attribute is not numerical, I still want to include it in the result of the dot describe function. And now we have the make, the model, the year. And for those attributes, we can have the count and the number of unique values. For instance, we can have the number of unique make, the number of unique models, and the top here represents which make is the most represented in the data set, which model is the most represented in the data set. And that's really it. The mean, the standard deviation, the mean are non-NaN because there's no way we can get the mean for those categorical or non-numerical values from the data set. And that's also a very good way to kind of know what um, the numerical values are spread around the data set, or sometimes how they are spread around the mean, and what are the minimum and the maximum values, and how, like, what is the gap between the minimum and the maximum value. It's pretty awesome. And a pretty good way, instead of using the dot function, the dot info function to know the shape of the data set, just use the function dot shape. And the function dot shape here is here to tell you how many rows and how many columns. That's it. Pretty good, simple and accurate. Um, and as you were speaking before, one of the best ways to determine the missing value, if the attribute have some missing values in the data set, is to use the dot info function. The best way to do it is to use the function is null, and you can use sum that tells you in total how many missing values each attribute has. For instance, we have when the value is 0, it only means that the attribute has no missing values, which is what we are driving when we work on a data science project. We don't want any sort of missing values to influence or to force the results of our analysis. So we want to make sure there's no missing values, because missing values are, are dirty data. Yeah, and then here we can see that we have the engine type presents 3 missing values, the engine H with 69 missing values, and other columns present way more missing values than others, like market category has 3,742 missing values, which is a lot comparing to the size of the data set. We have 11,000. That's a pretty high number. Now, after identifying which column have missing values and how many are they, 1, 2, 3, 4, 5, the next step is obviously to handle those missing values by either removing the columns, the rows containing the missing values, or replacing with the value that makes sense, or just removing or dropping the column anyway. So since you guys already know that from the previous tutorial, we said if the number of missing values is less significant than the size of the data set. For instance, 3 is very less significant compared to 11,000 entries, 6, 9, 30, and 6. We can go ahead and just remove the data rows that contain those missing values, and we are doing it right here. So, we drop any missing values. In place equals to tells me that I want the result to be directly applied to my data set, and I want to keep the updated result as my new data set. And what about the market category column? For the market category, you have two options. Either we remove that column completely from the data set, or we fill those missing value with values that make sense. There's no way we can remove the data rows with missing values. We are going to be losing a lot of information if you do that. And we want to have enough information to perform and to get accurate insight from the data set. So losing 3,000 rows out of 11,000 rows is no way we can do that. And so when you look at market category, it's not really something we are interested in when we're purchasing a car. Usually the most important attributes are the make, the model, the year, and sometimes the vehicle size, sometimes the highway MPG, but usually the market category, even if I go up here, I see the market category. It's really not something we are just excited about when we're purchasing a car, no matter how good, the market categories for this luxury performance and everything. It's just really not the most accurate or appropriate feature to look at when you purchase a car. So we are going to be dropping this column entirely to take that away and remove that entirely from our data set. And this is what we're doing here. Again, in place equals to means that we want the results or the changes to be applied directly into our data set. And here we have to specify the axis. Because we are removing a column, the axis is 0. If we were to remove a data row, for instance, if we were to remove the first row of the data set, axis was going to be equal to 0. And we do that. And now let's see how many missing values we have in the data set now. 0 missing values. If you want to know how many missing values we have after performing data cleaning, for each attribute, 0. And we see that there's no market category in the data set anymore. Good. We have a clean data set, at least clean in terms of missing values. Let's move forward with the next step of our EDA, which is to remove duplicates. So usually duplicates are just dirty data or like supplemental data we do not want to in our set of data set, just because those supplemental data set do not give us any sort of extra information about the data set, because it's just like a copycat version of a data point that already exists. We do not want any sort of copycat. We want unique data points to get more insights about the dynamic of the market, the car markets in today's economy or in today's world. And so when you use the function ilog, the function ilog helps you to retrieve some rows in the data set using the indexes from 11 to 15. And usually when we go from 11 to 15, we always go from this number all the way to this number minus 1. That's the reason why you see 11 to 14 instead of 15. That's just how, that's just one of the rules of Python, and we can't do anything about that. And so and you guys, if you pay attention to the 11 and the 14 rows, they have the same make, the same model, the same year, the same engine type, the same everything, the same popularity, and the same price. Those are duplicate, those are identical rows on the data set. And, having identical rows does not really help us getting more information about the data set. So we have to remove those extra uh, duplicated rows to stay only with the unique rows, because those extra rows are useless and are probably going to um, make our analysis bias in the wrong way possible. So let's get rid of those duplicated rows. However, I'm going to tell you guys, this is the worst way to identify duplicated rows in the data set, because sometimes, and this is really what happens in real life, is you have a data set and you kind of just, the data set is large. You don't know how to identify duplicated rows if you just go by playing with the values, by playing with the indices 11 to 15, and maybe from 11 to 15, there's no duplicated rows, you go from 15 to 19 now. That's going to be time consuming, and most of the cases, you're not going to get any sort of really good result from that. So the best way to identify duplicated rows is to use a function given by Python called duplicated. This is a very good function that tells you how many duplicated rows we have in the data set. And once we run that, whoop, 720 rows. That is a lot. But let's see what is the shape of the data set before the duplicate. And then now, once we identify that there are some duplicated rows, we can just get rid of those duplicated rows using the drop duplicates function. And we will see the shape of the car after that. So we went from 11,812 to 11,092 data rows, which is pretty good. We're still under 11,000 range. Awesome. And second step down, let's move on with the data type. So you guys have seen that once you use the function .info, you already have some information about the attribute, starting from the make model and the missing values and um, the data type is also something that you can get from the .info function. But the best way to know the data type for each attribute in the data set is to use the dtype function right here. And it's just like, it's kind of like a series where the first column is represent all of the attributes and the second column, the data type for each attribute. For instance, the make is an object, the model is an object, the year is an object, the number of dollars is float, pretty good. However, just look at this attribute and the data type for this attribute, float. Number of doors is float. Can you imagine having a car where the number of doors is not an integer? Like the number of doors is, for instance, 2.5, 3.5, 4.5. I've never seen a car with that type of number of doors. So in this case, even though float is not the wrong data type for this attribute, it's not the optimal one because we expect the number of doors to be integers, only integers and not even float. So we are going to be changing the data type from float to something that really makes sense for integer. And how do we do that? We do that using the function as type integer. And we call the column data type cars data the number of doors, because cars data the number of cars data number of doors as type integer. That is kind of changing whatever data type was originally associated with number of doors is going to be now integer. Perfect. And this is what we want. And if you want to look at how the data looks like after doing this, you can look at the number of doors now. It's not, oh, no, I didn't run this code before that. There we go. Integers now. Perfect. The data set is getting cleaner and cleaner, and it's probably well cleaned now. So far, we have done data cleaning, missing values, removing duplicates, data type as well, and just making sure the data types are correct for each attribute. And we are good when it comes to data cleaning. But for EDA, the only idea of EDA is not to clean the data, but it's also to get some basic statistics about a data set. By the way, data science is really only about statistics and using those statistical analysis or those statistical results to get more insight and to create now your model or to use those results in a business setting to solve any problem you are trying to solve with it. So let's get started and get some basic statistics about the data set. Well, you guys already know what the describe function does and how it looks like. So we're going to be jumping on the statistics that are the most used when you work on a data science project. So in our problem, we are interested in the return price, but we want to know out of what we already have in the data set, the information about those cars and their return price. We can ask this question, what is like the average price of cars in the market? What is the average price of cars in the market? What is the minimum price of car? What is the maximum price of a car? And all those informations are pretty good. Sometimes, why do we need the average price? Sometimes we need the average price to know, to kind of determine if our car is worth less than the average or more than the average in the market, and using a function that mean. And the average price is $41,908. And this really represent what we see in the market. 41,000 is a pretty accurate price. And I've seen myself cars that most of the cars like BMW, all of those cars that all those cars with good make, model, good year are usually worth $41,000. Some are way cheaper, some are way more expensive, so but that's the average. And so with that being said, what if me I want to know what is the minimum because I don't have enough money and I want to know what is the minimum price to get a car, just to get a car, and I print the minimum value and the minimum price $2,000. With this $2,000 and with this information, you know that okay, if you have $1,500, you know that it's not enough yet to purchase a car. Now you have to get some additional money to be to help of getting a car in the market in today's economy. And what is the maximum price of a car? What is the maximum somebody has already spent? Or what is the maximum retail price in the market from the data set? It's $2 million. Some cars are even worth more than that, but based on your financial situation, you can purchase a car for $2 million. If you're rich enough to do that, why not? But someone like me who is not rich enough to purchase a car of $2,000, I'm only interested in purchasing a car for the minimum price possible, and I see $2,000. So once I get $3,000, I know that okay, even if it's gonna be harder to get a car, I can still use a used car. I can still purchase a used car worth $3,000 that can help me to go to work every day, go to school, go to whatever places I want to go, grocery stores, visit families, visit friends. And those are some of the information you learn from the data set, some of the insight you learn from the data set, and use those insights to solve a real life problem. Like my problem is I have $1,500. I don't know if $1,500 is enough to purchase a car. How do I know if it's enough? You purchase the minimum value is $2,000. And then you're like, oh, okay, $2,000 is not enough. So work hard, get $2,000 and go to the market again. You will get a car for $2,000 for sure. This is how we solve real life problem using data. See how fascinating data science is. And I'm very happy that you guys are also learning data science like me. And sometimes you also want to know the standard deviation. The standard deviation usually tells you how the prices are spread around the mean. And the standard deviation is 61,000. Pretty accurate. And another function for statistics is the value count. This function tells you for each attribute the unique values for those attributes and how many record of those values we have in the data. For instance, the transmission type, we want to know how are the unique transmission types we have and what are how many records of each transmission type we have in the data set to tells you, okay, let's say me, I want to purchase a car and I'm only the attribute I'm the most interested in is the transmission type. And with the transmission type, I don't know which transmission type to buy because I don't know, I don't have enough knowledge about cars, transmission types and everything. And the only thing I want to know is which transmission type is the most used across the users in our data set. And I would just use that transmission type as a placeholder for my purchase. So I go to I use the data set and I display each transmission type and their record. And we see that automatic transmission type is the most used or is the most represented in the data set. And me, I say, oh, okay, automatic, it's pretty accurate. So I'm just going to choose a car that has an automatic transmission type. This is another problem I solve using data sets, using some of the statistics, basic statistics from the data set. Before that, I was not able to know which is the most popular transmission type, but now I know using the statistics. And also, really, let's do the same for now, our cars data, and just to know what is like the most the most common price for cars in the data. I said, thank God it's $2,000. So I'm pretty sure now if I have $2,000, I can purchase a car with that money. And I mean, I'm just happy because it's just fascinating. Like the questions you can answer directly using the data set and using those very basic statistics. They look basic, but the problem they can solve are limitless. It is no way to speak of how powerful data science is once you start diving deep into it and once you start understanding really the concept of data science. And I'm very happy that you guys are on this journey with me. Thank you very much. That's it for today. We've completed a very like a complete, thorough EDA, and now you guys know how to complete the EDA. And next time I will challenge you to do it using this data set, and for further learning on your own, you can do a new data set that you find online. Take the data set and just follow these steps and what you've learned previously to craft or to get those insight from the data set. And this is really what data science is, using those statistics, mathematics, statistics to get those insight and use those insight to solve some real life problem uh in what any problem that you face in real life. Thank you very much, guys, and see you next time. Thank you for watching.